Good afternoon, everyone. So, welcome to Tech Talks, and today's topic is Introduction to Go language. This is the official mascot of Go language. It's called Gopher, and this is an actual animal. So, please don't compare it with anyone. If I talk about the origin of Go language, it was developed at Google to solve some of their problems. And the guys who designed it were these three guys: Robert Griesmer, Rob Pike, and Ken Thompson. And the purpose of Go language. So, guys, you know that there are hundreds of programming languages already in the industry which are matured enough to develop efficient and scalable software. So, why did Google came up with another language? So, I think it's a fair question to ask because the day we have to learn it, and it's worth to know if it is good to learn about this language. Guys, so the languages that are very popular and mostly used were introduced something like 20 or 30 years back. And at that time, the paradigm of software engineering was a bit different from now. So those languages were developed to target the issues faced by developers at that time. But now it's a different story. There's a lot of advanced technologies like cloud technologies, distributed computing, and containerizing and all that. So the guys in Google thought that it's a good idea to come up with a modern language which can address the concepts of the present software engineering paradigm. So that's how Google came up with Go language. And in the paper, the purpose of Go is to develop efficient and scalable software. So by the end of the presentation, you can see for yourself if that goal is achieved. So let's get started. I will be doing the demonstration alongside the slides as well. So to get started, all you have to do is go to golang.org, and download the distribution and install it. So I have already installed that in my machine. So just to verify it, I can type Go version and it will show the version. So here you can see the Hello World program. You can see even the Go language is trying to make fun of us with these letters. So in the top line, you can see the namespace, and then we have the import statements, and then we have the main function. This is actually the entry point of the Go program, and if I run this, it will print hello Chanting Chung or whatever this means. I don't know. So if we want to do this in the local environment, what we have to do is we can save a file with .go extension, and let me add a hello world code here and save it. So if I say go run and the file name, it will print the hello world message. So this is how we run Go programs in our local environment. Moving back to the presentation. Next one is programming constructs. So these are some usual stuff that are there in all the programming languages. So I'll just rush through these things. In Go language, there are 4 data types: numeric, boolean, and string and derived. Derived types would be pointer, array, map, structure, and interface, and there are some others as well. And I hope you can remember what pointers are. And let me quickly demonstrate how we can define variables in Go language. So in this line, you can see that I have added var a int equals 5. So this is the variable name, and the type comes after variable name. And even if we do not specify the variable type, Go is smart enough to identify that these are integers. And here this is the assign syntax, and when you are initializing and assigning or declaring and assigning, you can just use equal sign. So if I print the value of a, it will print 5. And just to remind you about pointers, this is how we can pass a pointer to a function. So this will print the memory location value of this variable. So let me save this and run this. It's complaining that these variables are not used, so I just comment it, and yeah, so it printed 5 and the memory location of a because I printed the pointer. And just to quickly show another example with pointers, let me add this function here. It will just change the value of whatever value we pass to here, and if we print the, as you expect, the value will not get changed because we are just passing a copy of the value. Let me quickly run that as well. This is just to remind you of pointers. So if I make it to accept a pointer and change the value of the pointer, and then the value will get changed to 10, because now actually we have to pass the value of the pointer here as well. So you can see the value of a has been changed. So this is how pointers work, just to remind you. And the next topic is loops and conditions. So in Go language, there's only one type of loops, which is for loop. And when it comes to conditions, you can use if else or switch case. And switch case has a simpler syntax. It doesn't have the keyword break. Then we have arrays and maps. Let's move on to the examples again. So if, this is how you define an array, and this is how you initialize an array. And if you want to print the values of this array, you can add the for loop like this. This is a special keyword. What this means is, for the range of y, which is from here to here, print the value of y. So let me save it and run. So it prints the values of this array. And talking about maps, let me show you an example of a map. Before that, if you want to access the index of this looping variable, you can just say I, and if you access it from here, it will print the value of I as well. Let me quickly show that as well. Here you can see the index has also been printed. So moving on to the maps. Map is something that we use to store key value pairs like a dictionary. So what this means is there's a map of integers and the key would be string. So this is how you assign values to a map. The key should be a string and the value should be integer. And if you want to print the value of map, you can just say print the value of map. So it will print 10. And you can also define a map of maps as well, like this. I'm not going to go into details, so I just demonstrate the basics. So let's move on to the next topic. Next we have functions. So in Go language also we got the usual functions. but there are some special flexibilities in Go language functions. Let me demonstrate those. So if you look at this function, if the input parameters are of the same type, you don't have to specify the type for each parameter. You can just list the parameters, and at the end you can specify the type, and this one would be the return type. And the next one is, if you look at this function, what this does is accepting a dynamic number of parameters, and in this for loop I have looped through these parameters and printed the value. So if I do like 4, 6, 7, 8 or something like that, it should print the values of all these past variables. Let's see if it works. Yeah, you can see the past values are printed, and that's all about functions. So let's move to error handling. So Go has these three keywords called defer, panic, and recover. Let's see how we can use these to do error handling. Let me bring up a different example. So first, let's talk about the defer keyword. You can see I have a function called return message, and it prints something to the console. And in the main function, I have called it with the defer keyword. So what this keyword does is, before the program execution returns from this main function, it will execute whatever in this function as the last thing. No matter whether we put it here, or at the end, it will always execute it as the last thing before the main function is returned. So let's try that here. So you can see I have a bit at the top, but it has executed as the last thing. And if I talk about panic, this is a sample panic function. So what this panic keyword does is something similar to throwing an error in C#, let's say. So if we panic from here, the execution will immediately exit, like when we throw an error from C# code. So the only thing that can stop exiting from this point is to add the defer function in this method. So now what happens is, when a panic situation occurs, it will try to exit from here, but before that it will execute whatever inside this function. And this is the concept that Go uses to do error handling. If I bring up a different example here.
Chamil,
Yeah.
Chamil, so the defer is not like a thread execution, but it's sort of scheduling to exit
Yes.
whenever the method cleans up or the returns
Yes.
or
Yes.
exception finally block, right?
Yes. It's a finally block.
Okay.
So here, so I have the main function here. So there's execute panic function, which will panic, which is equal to throwing an error. And so I have added this recovery function as well. And in the recovery function, let me describe that later. So let's first see what happens when you run this. Okay, so you can see the panic situation has occurred. It has never reached this line, because after the panic, only thing it does is to execute the defer function. So it has never printed this line. Now in the defer function, you can see there's a keyword called recover. What this does is whatever you pass to this panic keyword or the panic situation here, you can recover it from the defer function like this. So then you can process the panic from within this function, and you can continue the execution. If this was not here, let's run that as well. You can see the program has exited, but because we added it here, even the main function is getting executed. You can see after the panic, it will go here, and then it will handle the error from here, and finally the main method execution will happen, unlike in this place where it returns immediately. So this is how Go language handles errors. But one important thing to note is that even though I discussed this under the topic of error handling, this is not limited to error handling. You can even design workflows with this defer and recover panic things as well. So let's move on to the presentation. Then the next two derived types would be structures and interfaces. This is how you define a struct, and this is how you define interface. So I'm not going to go into details with these. Yeah, so far we have talked about the usual stuff that every programming language has. But guys, so if you can remember in the third slide, I said that the purpose of Go is to develop scalable and efficient programs. So this is how it tries to achieve that. Go language has a strong and powerful concurrency mechanism. So let's move on. Before moving on to the details, let me explain the difference between parallelism and concurrency. In parallelism, application splits its task into smaller subtasks and then run each of them in different CPU cores in parallel, and it requires the hardware support essentially, and the tasks are independent from each other. And whereas in the concurrency based execution, application executes multiple tasks at the same time, but they don't have to run simultaneously. That means even if you start two tasks at the same time, I mean, they can progress independently, but they do not need to wait till the other one completes. And concurrent tasks can run on one core processors as well, and there can be interdependencies between tasks. For example, one task might have to depend on the other task's output, or they may have to use a shared variable or something, shared resource or something. So just to make it more clear, let me explain this with the real world example as well. So let's say you and your friend are living in two nearby houses, and both of you get up at 6 a.m. and get ready and go to work at 7 a.m. So because you are living in two different houses, both of you can get up separately, wake up separately, and get ready and go to work as planned. So this is the parallelism approach. Both of you have different resources to make use of, and you can do it parallelly. But let's say you guys are living in one house in a shared basis, then so if there was no concept called concurrency, what would happen is one guy has to wake up at 5 p.m. and finish his work at 6, and then the other guy has to wake up at 6 and finish by 7. But because there is this concept of concurrency, both of you can get up at 5:45 or something, and then start working, getting ready. But there will be constraints. For example, if you want to use the bathroom and if it is already occupied, you have to wait till the other person come out. or let's say if you are cooking the breakfast together, and if you are supposed to prepare the sandwiches and the other guy is supposed to fry eggs, you can't make your sandwich until the other guy fries the eggs. So there will be constraints when you use the shared resources, and when you have to depend on other person's outputs and like that. So at the end of the day, you can utilize the same house and get the work done. So that's the model of concurrency. So guys, if you think about it in a programming sense, the most popular languages that we use are really good at parallelism, but it's a bit hard to achieve concurrent programming with those languages. Even if you think about C#, we can use parallel for loops or task groups as long as they are independent. But if the tasks are interdependent, it becomes harder. Actually, I'm not sure if at all it is possible to for a task to return a value required by another task before completing itself. So the true strength of concurrent programming cannot be easily achieved by these mainstream programming languages. So now let's see how Go language achieves this. So I'm going to talk about these 5 concepts. Actually, there are more concepts, but today I'll be talking about these 5. Again, let's move to an example. Okay, so I have this count method which will print the value that we pass from the from variable, and it will be an infinite loop, and there will be a sleep of 500 milliseconds just to see the output clearly. Now if I run this, so as expected, it would go on and print the word cat, and it will never come to this line because this is an infinite loop. So let me do something like this. Now if I run this, you can see both cat and dog are printed. So what happens here is when I say go count, uh, I'm saying that execute this function in a different as a different task in the background. So we call this as go routines. So actually the main function itself is a go routine. So what I have done is to create a go routine or spawning a go routine to run independently in the background. So that's why it will print cat, and the main method will go to this line and it will print dog. Now let me add the go keyword here as well. Now you can see nothing has been printed. That's because what this main function has done is spawning these 2 go routines, and it has returned from here. So with before these 2 go routines execute anything, the function execution has finished. One thing we can do to avoid this is to add the sleep like this, and it will wait here until these functions will print these words. But this is not a good concurrent programming solution, and this brings us to our second topic, which is wait group. Wait group is nothing serious. Let me add an example of a wait group. I'll make this this as well. So I have to add this package as well. So what this says is the wait group needs to wait for one go routine to finish until the main method can continue, main function can continue. So to wait, we have to add this keyword, this statement. Now it will wait until one go routine finishes. So how does the wait group know that this go routine is finished? One thing we can do is to add the statement like this here, and we can get a pointer to this wait group and inform that this routine has been completed. But this is not a good practice because this will mess up this function. So a clear or cleaner way would be to do this in a anonymous function like this. Okay, so let me run this. Oh, I need to wait as well. Sorry about that. Now it prints because size from 1 to 5, it will print cat for 4 times. Yeah, that's about these wait groups. And
So Chamil, this add one, is it saying how many done events that it has to wait for? Is
yeah,
that
it's
the meaning?
actually a counter.
Counter,
So
okay.
the counter has to be 0 in order to proceed.
So whenever someone calls done, it's like increment the counter, increment towards that
Decrement.
final value, decrement the counter,
Yeah,
right? So
yeah,
yeah.
yeah. Okay, so
So so it looks to me that inside one anonymous, so you can even call done. If you wanted to, you could even call done in the middle of a parallel task as well, right? If you
yes,
wanted, you can call it multiple times also.
yeah, but you have to make sure that the wait group in the main method should be accessible from wherever you call it from.
Exactly. I mean, if you passed it as a pointer and access it from inside the function, although it's a bad practice, you could
Yeah,
mark it as done multiple times, right?
yeah, yeah. Okay, so like I said, so the next topic is the most important one. Uh, Channels is something that we can use to communicate between two Go routines. So in this example, so far what we did was to print something to the console. So what if this Go routine needs to communicate something back to the main Go routine? Um, Let me clear this first. So to do that, we need to introduce a channel here. And in getting rid of this one. Okay, so now I have introduced a channel to this count function. Uh, Actually, I need to separate. Uh, so in this syntax, a string indicates that this channel would communicate strings, and in this syntax, uh, this means the arrow towards channel means we are writing to the channel, and in order to read it, we have to add some code to the main method as well. Okay, so what I have done now is created a channel in the main function, and I'm going to pass the channel here, and this guy will write to this channel, and this guy will read from this channel. So the arrow going outwards this channel means we are reading from the channel, and now we are printing the value. One important point here is when sending or receiving messages, the execution is blocked. So in the main Go routine, this line has to wait till somebody writes to this channel, and in this count method also it will get blocked here until somebody is ready to accept whatever you write to here. So in both places the execution will be blocked. Now if you think about this carefully, this is achieving two things. One thing is obviously we can pass values between Go routines. When we write from here, it can be accessed from here. And the other thing is because in whatever order these two functions run, the main Go routine will always have to wait till the count function will reach this point. And in the other hand, if the count function reaches this point first, it will have to wait till main method function execution comes to this point. So this is actually a synchronization of two Go routines. These channels make sure these two Go routines are synchronized, and we can also send messages in between these channels too. Now if I run, yeah.
Chamil, in the main method, can't you just print line C, or like do we always have to retrieve
Yeah.
the
No,
channel value?
we can do this. So it will directly print to this. It will get passed to this println function. So if I run this, it will print one cat because whenever one value is received to this message variable, it will proceed and exit from the function before this guy will send another one. And if we want to print all of them, we have to do this. In a for loop, we are accepting these channels. Now let me show you something interesting. Okay, so now for 4 times it will print cat and it will go to deadlock. Can somebody explain what's wrong here, if you understood this properly?
Both are waiting for the other, right? So the main method is requires it's doing a read operation which requires a write, and the other guy has, once the other guy has finished executing its iterations, there's no one to write.
Yeah, exactly. So when this guy is finished, which is printing 4 times, this guy waits for another input which will never happen, and Go language detects that and it will display a deadlock. So to avoid that, we can do something like this. We can say after this count function is done, we can say close the channel. And for this to work, we have to do some changes in the main function as well. So now what this does is from this channel, this will receive the message, and it will also receive whether the channel is open or not. And if it is not open, it can break out and complete the execution. Let me run this now. Yeah, now there's no deadlock.
So Chamil, by default, will the channel always return its status, like if it's open or closed? Does it always do that?
Yes, but we need to capture that if we are going to use.
Okay. So it returns in this, or it's kind of like a tuple.
Yeah. This actually Go syntax. You can it's like you said, it's receiving a tuple.
So the open is it? I mean, can we use another like variable, or is it kind of a is that the only variable we can use, like the word open?
No, I think the second value it passes would be
Okay.
whether the channel is open. I'm not really sure about that. However, you can access the status of the channel,
Okay.
and there's a cleaner way for doing this without writing all this code. We can just say print the range of the channel. Now it will for the span of time when the channel is open, it will print these messages. Okay, so let's move on to the next topic.
So even if you do range C, you have to still close the function, close
Yes,
the. Okay.
otherwise it doesn't know when the range would end. Um, so yeah, the next topic is buffer channels. Let me bring up an example for that as well. So can someone tell me what would happen here? Any answers? Okay, I'll give the answer. So in this line 11, we are writing to this channel, and if you can remember, I said that this line is blocked until someone is ready to accept the value that we are passing to this channel. But that part happens in the next line, so this will go to a deadlock. This is where our next topic comes in, buffered channels. So when you are defining the channel, you can give a buffer as well. Before that, let me run this one and show you. Yeah, it's going to a deadlock. Now let me add the buffer here. Now it prints. So until the buffer is full, we can pass values and it won't get blocked. Even if you add another thing here, it will proceed, and if we add another one here, it will get blocked. Now it will. So by default, the channel buffer would be 0. So that means if you do like this, only one time we can write to the channel, and still it gets blocked. And if we do this, it means one. If we write one value, it can proceed there, because there's one buffer left, and if we fill up with two values, it will get blocked because there's no buffer remaining. So let me go to a example with this. Actually, I'm going to show another keyword with this. So inside the main function, I have created two channels, and there is one function which will write to this channel every 500 milliseconds, and there's another function which will write 2 seconds a time. And now when we print this, let's see what happens. Now you can see we expected to print 4 of these items per one of these, but it doesn't happen here. So the reason is there's no buffer in this channel, and therefore when it executes this line, it will print this, and when it executes this line, it will wait for 2 seconds. No matter 4 of the other items arrive here. Actually, it doesn't arrive here. It will also get blocked until this guy is ready to listen again. So because of this bottleneck, you cannot print that. So to get rid of that issue, we can do something like this. Now what happens is, it's like a switch case statement. So if a message is received from channel 1, it will print that, and if a message is received from channel 2, this will print that. So these two will happen independently. Let's have a look if it happens. Yeah, now you can see it happens properly. It's about that. And as the last concept, we have the worker pools. So worker pools are actually useful when there's a queue of items or a batch of items to be processed, and worker pools can read from that batch and process each item independently. Let me add this example here. Okay, so sorry. Yeah, so in this worker function, before that, let me go to the main function. So I have created 2 channels. One is jobs channel and the other one is results channel. Both of them having 50 of buffers. And here I'm writing to this jobs function for 50 times. And then I close the channel, and in here I read from this result channel and print the output to the console. And in the worker function, what I do is accept this jobs channel. In this syntax, what we mean is this particular channel is for receiving messages, and here the arrow is towards the channel. That means we are writing to this particular channel. And to view things, I have added this worker index as well, so it will convert the job number into a string, and it will add the worker index and the current timestamp, and it will print. It will not print, actually it will write to this channel, and this guy will print it. So let me run this with just one worker. So the worker index is 1. Let's see what happens here. Okay, so the worker 1 has printed all 50 items, and the time it has taken is from 10 seconds to 22 seconds, which is 12 seconds. Now I'm going to uncomment these items. So I'm adding 3 workers to process this job of items. Now if I run this, it runs faster. You can see that all 3 workers have been processing these items, and if I see the time taken from 52 seconds to 56 seconds, which is just 4 seconds. So you can see how dividing work into workers can make your program efficient. So guys, that's in for the concurrency mechanism, and there are lots of other topics or areas that you can learn about Go language. So this is just an introduction, and that's it for the presentation. Thank you for listening, and if you have questions, please do ask.
Chamil, is there any close equivalent to a callback or a sync await kind of thing? Callback or asynchronous completion kind of thing, or is it like does that get achieved by this that channel?
So you were asking
So let's say HTTP call like a promise or a C# async await or callback kind of thing where we execute a Go routine and after its completion we get the return value back. But that whole asynchronous execution concept without blocking the thread, the program execution blocks, but the thread itself doesn't block.
I haven't really come across such a concept in Go, but maybe their intention is to avoid that kind of scenarios because we can pass messages between channels. You don't have to wait till the other one completes.
Yes, could be, definitely. Yeah.
And there are other things like mutexes and some other things as well. So maybe there's a way as well.
Okay.
Any other questions from anyone? Okay, then I think we can wrap up. Thank you for listening.
Thanks, Shamil.